Welcome back to Calculus, everybody. In this video, we'll be talking about the second derivative test. This is another way to classify the local extrema of a function. Instead of using the first derivative, this time we'll be using the second derivative to classify our local extrema. So our second derivative test says that suppose f prime of c is equal to 0. This means that c is a critical point, but specifically a critical point that has derivative 0. And we also need f double prime to be continuous over an interval containing c. The second derivative says that if f double prime of c is positive, then f has a local minimum at c. If f double prime is negative, then f has a local maximum at c. And if f double prime is equal to 0, then our test does not tell us anything. So this is a little bit counterintuitive, and we have to pay attention to this, right? So we have if f double prime of c is greater than 0, then this gives us a minimum. The way that I remember this, because usually when something is, positive, we associate it with maximum or something like that. The way that I remember this is I think of the function f of x equals x squared. That's an easy function. If I take the first derivative, this is 2x. If I take the second derivative, this is 2, which is positive. And obviously, x squared looks like this, which has a local minimum. Right? So whenever we have a positive second derivative, we have a local minimum. That's how I remember this. Maybe that will help you too. So let's consider the function f of x equals negative x cubed minus 12x squared plus 30. There's a critical point at x equals 0, where f prime of 0 is equal to 0, and we want to use the second derivative test to decide if this critical point is a local maximum or a local minimum. So lucky for us, we already have our critical point. I just need to find the second derivative and then plug in this point to see if our second derivative is positive or negative. So f prime of x is equal to negative 3x squared minus 24x. That 30 goes away. F double prime of x is equal to negative 6x minus 24. That's my second derivative. Now I plug in my critical point, x equals 0. F double prime of 0 is equal to negative 6 times 0 minus 24, which is equal to negative 24. Since this is negative, this means that we have a local maximum. So x equals 0 is a local maximum. Great. Awesome. That is it for this video.